Hey, so I made a tool that will ray a grid onto geometry down below. And I feel like this would be useful definitely for effects. I was doing this very often for Titans, and I feel like it could be useful for animators as well. The idea being that you don't need, 16 different terrain meshes down below. You just need one grid that's optimized for the area that you're using it for, and that kind of thing. So let's walk through it. This is actually a dynamic mesh. Essentially, this steps 600 is the final resolution for what it's going to be. So let's just run this and let's just see what happens. So we're going to say this compute volume and raycast grid onto geometry below. So this button does a series of things, but when it's done, oh, you have to have real time turned on. It will create the grid and raycast it down. You can see all the point positions have been updated for this grid down below. Then what you can do after this is raycasted is you can say bake the static mesh, and it's going to put it right here in this path. And if it's not available, it's going to create that path for you. And then once that gets created, you can see inside of here, this is our new static object. And you can see here's our new static object. It's got 700,000 triangles and however many, and Nanite is no longer enabled, which means you're seeing 100% of the actual original mesh. So to actually use this tool, there's several things that need to happen. To generate on a high amount of mesh, you need a loop iteration. So if you go up here to project settings, edit project settings, and you type in loop iter, you'll see maximum loop iteration count. By default, this is going to be 100,000. You're just going to want to say 1, 0. Just hold that 0 button down, and it'll truncate it to not do an integer overflow. So just make sure to set that. So once that's done, you also need to have the plugins enabled. You just go over to plugins and you type in Geometry Script, and you just make sure that this plugin right here is enabled, and then you'll restart your Unreal once this is enabled. That's all you need to do. And I'm going to be sure to put this tool set inside of the developers under my name for every project from now on. Right now it's in the engine just because that's where I make my tools, but I'm gonna put it in the developers tiler so that you guys can have access to it. So the way it works is you create, let me start over. So let's create a few terrains. I'm gonna start with just this one because this one's already set up for us, and I'll show what that means in a minute. So you can see, okay, here's all of our terrains. We have like 5 terrains, and let's create our new mesh here. I'm gonna zero it out. I'm gonna scale it way up, and let's just move this up. So you can see this is actually a dynamic mesh. Essentially, this is the only way, it's using Geometry Script, and it's the only way that you can actually dynamically create objects like procedurally. So if you modify this number, you can see what's happening. So what ends up, this preview steps is what you're previewing when you're moving this mesh around. The final steps, or the steps here, when it actually gets projected onto the geometry, this is what it's going to be. Now you can turn your preview steps into your actual steps to see how it's going to look in the final mesh. This radius parameter, radius around grid, is looking at the transform of this handle, basically like the pivot of this grid, and then it's looking at all the actors, static mesh actors around it, and it's looking at their transform, their actor location, and it's determining the distance between this transform and this transform, and it's between this transform and this transform, what is the distance between those two transforms, and if it's less than this number, so it's basically attempting to like create a giant sphere around this grid, and anything inside of that sphere it's gonna activate based on that static mesh. So that's what this radius is for. So while the tool can run as is on all these static meshes, it won't be very optimized. And the reason for that is because the Geometry Script as a plugin doesn't support Nanite. So essentially Geometry Script is running over all the original static mesh geometry, which in the terrain static mesh's case, This is 6 million polygons easily, or 7 million. So we need an easy way to optimize these static meshes. So what I've done is create a tool that does just that. And really this could be a tool within itself, and it does most of the work. What it does is for every mesh inside of the radius, similar to this other tool, how we have a radius here, it requires a radius of its own. And it's also looking at the actor transforms, as I discussed earlier, to determine the distance. Because you don't want to take every static mesh in the entire world. You only want static meshes within a certain distance of this grid. So that's what this threshold is for. Now this threshold does need to be pretty high. I find that 15,000 may not be enough, and you can look at try to guesstimate the distance yourself to see oh, how far away is this. Actually, I may end up putting a distance checker to see that might be a good idea actually, to see how many meshes are in that certain area. It returns every static mesh actor inside of the radius around this grid, and it returns a list of all the static meshes, but it's a unique array, which means that it won't return the same asset twice. So in this case, because it's terrain 01, we're only getting one single terrain 01 when we run this tool. We're only going to get that one static mesh actor, and it's going to do all of its work on that one static mesh. It's not going to return it multiple times. And it modifies each of these static meshes nanite settings to this percentage cutoff point. So every single one of the meshes has this keep triangle percent. So by default, it's set to 100. So keep 100 of the triangle percent. And if you set it to 2, it's going to keep only 2% of the original static meshes. So it's going to apply those nanite settings to this static mesh asset, and then it's going to just take all these static mesh actors and merge them all together into a single static mesh, and it's going to create a new asset where you specify in the tool, so under game. So let's just see how this works. So right now this percentage is set to 2, and it's not going to change the nanite settings when the percentage of the triangles are already equal to each other. So if this is set to 2, and that way you don't keep modifying the same mesh over and over and over again. It's smart enough to know hey, this mesh has the same nanite settings as what this is, so I'm not going to change it. Now if I were to set this to 10, it would change it. But so we're going to say 2 here, and then it's going to put a new static mesh here in this path game. And so let's just do that. Let's just run it. Let's make this radius huge, because we only have these 5 static meshes. It's not going to be very, very big deal if we're overshooting this radius here. So we're preparing static meshes around this object. Let's see what happens. So here it's not optimizing the static mesh. It's already, because we've already optimized it. Now it's just making a new static mesh in this path. So here it's made a new merge static mesh of every single one of those terrain objects, and it's combined them all into one single actor. And this is super useful just by itself, because by default you have to use the convert terrain to static mesh, or in actuality what I'm using in blueprints is this merge actors set to merge. That's basically what I'm using, with pivot point being 0. That's super important. If you look at this terrain object now, if I look here, it's this merge static mesh. You can see we have 400,000 triangles and 240,000 vertices. And nanite is not enabled, which means the tool is going to be optimized now. So now when we use this tool and we say compute volume and raycast, and we have to make sure real time is enabled, let's scale this up because it needs to be larger. And there we go. Now you can see all the actors that are returned and all that. Oh, that's actually from before, sorry. Oh, let's set this to 20 so it's a lot more optimized when we move it around. So yeah, so that's how this tool works. So while I was recording this, I actually had an idea about how I could do this. So this controls the wireframe color based on the distance that you set this. Right now it's set to when the value is committed in that spin box. But if you want to make your own, you could even have it on value changed. So you could just replace this. Alt click on a wire to get rid of it. And then now it's live. And so if you don't have that many meshes, this is fine to do. To live update it, you can do it either way. Actually, I could set up a control to where it's live anyway. I'm gonna do that. But yeah, so this is something you could do. That way you know exactly what, and I don't think I can do this inside, at least not on a parameter callback. I don't think I can do that inside of this blueprint because it doesn't give me access to this parameter as a callback. Only in an editor utility widget can you do this. So this is something I'm doing. So here, the way I'm doing this is I'm actually just, every time that this value gets changed, it's calling this gather static mesh actors function, which I made. And all it's doing is it's saying if it's within this radius, then set the mobility to stationary, which is gonna change the wireframe color, and then set them, if it's false, if it's not within that radius, it's gonna set the mobility to static, which is what it should be. Now, if this happens to modify a bunch of meshes, it's okay. As long as you don't save out the level, it's fine. This is just something that I'm hooking up. And then you can plug this exact, like let's say you're happy, like, oh cool, I'm happy with this. You can just copy this number and paste it into here, and that way you know, okay, exactly which static meshes are going to get ran over. And it's also printing out exactly which static meshes are getting returned here also. So I did actually end up getting this working where it's live updating. When it's off, it does that live update. And when it's on, it does live update. And it's using, I just found this out, it's using this kind of control where it's running the function multiple times. It's the only way I can figure out how to do it. Thank goodness this is a function. But yeah, so this is kind of the setup. So yeah, that's what this is doing. Pretty cool. So I definitely learned a lot from this project. This was really fun. If you guys have any other tool ideas, I would love to hear them. Just let me know. All right, catch you guys later. Bye.